All right, homework 30 starts off with using a graphing calculator to solve a trigonometric equation. And we're going to use the Aleks graphing calculator to do this. The calculator is active on Aleks. But what you're basically going to do is you're going to type in one equation that's equal to this side, one equation that's equal to this side. So we're going to have one equation that says y equals sine of 2x. And then the other one, y equals negative 0.4x plus 0.9. So you can see how this works. I'm going to go over to the Aleks calculator, and so I'm going to grab my paper where I have those written down so I remember what my equations are. And so if I go over here, here's the Aleks graphing calculator. If we are going to graph something, we are going to hit the y equals. So y equals. We have to check the ones we're going to graph. We're going to graph two equations, so we want check marks in both of those two things. If you draw your graph and only one's showing up, go back to the y equals and make sure one of the boxes or both of the boxes are checked. So we said first of all we were going to do sine of 2x. So we're going to do sine, and then we're going to do 2, and we're going to use this one that says xt theta n. If we hit that, that's going to put the x in there, and we're going to say sine of 2x. On my other one, it was negative 0.4x. So we can just use the subtraction for the negative. Negative 0.4, again the xt theta. Negative 0.4x plus 0.9. So plus 0.9. Once we have our two equations in there, both of those are checked, we're going to hit graph. So what we're looking for is where do these two things intersect each other. There's 1, 2, 3 intersections, so we're actually going to end up with 3 answers. So what we're going to do in order to find those intersections is we're going to click on this thing here where it says intersect. It's going to bring up some little arrows. We want to drag those arrows close to an intersection. So in this case, I'm going to drag them, it'll let me do it here. Just close, it doesn't have to be exactly on. Once you're close, you're going to hit intersect, and it's going to tell you both up here and down here what the x value of your intersection is. We on these ones are going to round off to the nearest hundredth, I believe, if I go back and look, round to the nearest hundredth, and so 0.41 is going to be one of our solutions. Now I'm going to write that down, but when I mess with the board, it's going to erase it. Actually, there's my equation popped up. So 0.41 is one of my solutions. Now I'm going to erase that. What I do after that is I am going to hit OK. OK takes me back. Now notice on my graph my line disappeared. That happens sometimes. Just go back to y equals, make sure that second one is checked. For some reason the check mark wants to go away, and hit graph. Now my line should be back on there. I found the first intersection, now I want to find the second intersection. So I'm going to click intersect. I'm going to drag that over close to the second one. Doesn't have to be exactly on, but close. I'm going to click on the word intersect, and then it's going to give me the value both up here and down here. So this one is 1.396. I'd have to round that off to 1.40 then. So our first answer we had was 0.41. Our second answer is 1.40. Again, after you do that, you have to hit OK. Evidently my OK just erased the board. There it was. This time my line stayed. My line's still there, so now I need to find my third intersection. So I just repeat that. I hit the word intersect, I drag that over close to that third intersection, I click intersect down here, 2.9911, so 2.99, and those should be my 3 answers for that question. So again, just going back to our question, then the sine of 2x equals negative 0.4x plus 0.9, we would have those three answers that we got by finding the intersection. 0.41 was the first one we got, 1.40 was the second one we got, and 2.99 was that last one we got. So just as easy as punching it into the calculator and then finding those intersections. All right, so number 2, again, we're going to use the graphing calculator to solve the equation, and we're going to type in two equations, the first one being y equals the cosine of 4x, the second one being y equals 1.6x minus 1.9, and we're going to find the intersections to find out where those two equations have a common solution. So if we go over to the Aleks graphing calculator, we are first of all going to hit our y equals to get to our graphing. We're going to do two equations, so I'm going to check y1 and y2. And we said for y1 we were going to do the cosine of 4, and then we're going to use the xt theta, so we have the cosine of 4x there. For y2, we had 1.6x minus 1.9, so 1.6, the xt theta, 1.6x minus 1.9. Got my two equations in there. They both have check marks by them, so they should graph. I'm going to hit my graph. I see I have my graph here. If you'd like, because it kind of looks like it zoomed out a ways, you can hit the zoom. And I'm going to zoom in. There I can see my intersections a little bit better. I'm going to hit OK on that screen. And what we really want to do is the intersect. So we're going to do the intersect. And again, we're going to drag these arrows as close to the first intersection as we can. Doesn't have to be exactly on there, but close. Once we get it close, we're going to click on intersect, and then we're going to look for the x value. The x is at 0.650. We're rounding to the nearest hundredth, so we're just going to use 0.65. So 0.65 would be our first intersection, the first point that those two equations have in common. Once we want to do the next one, we have to hit OK. Oops, did the OK go? There, it went OK. Notice my graph sometimes disappears. Just hit the y equals and recheck that second line. For some strange reason, only the cosine curve wanted to graph. But now that they both have check marks, I can go back to graph, and they're both there. So I did this first intersection. Now I want to do the second one, so I'm going to click intersect. And now I'm going to drag that over to as close to the second one as I can get. Again, it doesn't have to be exactly on there, just close. Click the word intersect, and here we see we have 1.1718, so 1.17 would be our second solution. And then we're going to do the third one, so again we're going to hit OK. Get rid of that stuff on there. We're going to hit intersect again, and then we're going to drag that over to the third intersection once I can get a hold of it, which is up there. We're going to hit intersect again. We're at 1.7135, so 1.7135 would just be 1.71. So again, our three answers there, 0.65 was our first solution, 1.17 was our second solution, and 1.71 was our third solution. So for number 2, where we had the sine, or not the sine, we had cosine. Cosine of 4x equals 1.6x minus 1.9. Those would be the 3 points that those two equations would have in common. And if we go back to number 3. Number 3, we have the sine of x equals negative 0.2x plus 0.5. So our first equation, y just equals the sine of x. Our second equation, y equals negative 0.2x plus 0.5. And again, we want to see where those two lines intersect, or those two equations intersect, so that we can find the solutions that they both would have in common. So going back over to our graphing calculator, I'm going to hit the y equals. I'm going to clear out the top equation, clear out my second equation, and put my new equations in. So the first one was just the sine of x. So sine, the xt theta n key. My second equation was negative 0.2x. Here we use the subtraction for the negative 0.2 xt theta, and then it was plus 0.5. So we got our two equations in there. We hit graph. This one I can only see two of my intersections. Normally you'll have three. There's one there, so now I've got to zoom my screen back out. So I'm going to hit zoom, zoom out. Now I can see all three of my intersections. So I'll hit OK. Hit the word intersect. Pull that baby as close to the first intersection as I can. Hit intersect. And it has 0.4274. Since it's 427, I have to round that up to 43. So 0.43 would be the first point that those two equations have in common. I'm going to hit OK. I'm going to hit intersect again. I'm going to drag that over to my next intersection. There we go, somewhere close. See, I'm not even right on there. But when I hit intersect, it pops over to that as close as the next one is. And so we can see this one says 3.02, or 3.302. So 3.30 is going to be our second intersection. 3.302 would round off to 3.030. Hit OK. Get rid of that. Hit intersect again. Pull it all the way over to that third one, or at least close to the third one. Hit intersect, pops that on there, 5.611. So 5.61 would be our third intersection. So again, our first one was 0.43. Our second one was 3.30. Our third one's 5.61. And that was for the equation on number 3, sine of x equal negative 0.2x plus 0.5. 4, 5, and 6, we are going to do sort of the same thing we did before. We're going to use the graphing calculator to solve an inequality. So again, we're going to start out by just putting in two separate equations. Y equals the sine of x, and then on the other side, y equals negative 0.2x plus 0.5. So we're going to put those two things in on the graphing calculator. So over here on my graphing calculator, if I bring that up, clear that all out. That first one was the sine of x. I don't have to change that one. Sine of x, yep. The second one was negative 0.2 plus 0.5. Well, how handy. That was the same equations we had in problem 3 when they were equal. Now we're doing problem 4 where we're doing our inequality. So again, we would put those in. We would go to the graph. Now we were doing that we wanted, if you go back and look, the sine of x is less than or equal to. So this is my sine curve. I want the points where it's lower than my line. So my sine curve is lower here. Whoops. My sine curve is lower here, and it's lower down here. So again, I'm going to find my intersections because here I'm going to go from negative infinity to whatever this point where they intersect is. Then I'm going to do these 2 points from there to there. So again, checking our intersections. If I clear off my scribbling, I'm going to hit intersect. I'm going to move that over and hit intersect here. And so we said that was at 0.43. So this section of my graph is going from negative infinity to 0.43. Now this had the or equal to, so this will have a bracket, this will have a parenthesis. That's this section right here of my graph. I'm going to join that with the union sign, but of course that's going to erase. And so when I go to the next part here, then what I'm going to do is find these two intersections. So intersect, move that over here, click on intersect. That one was at 3.30. It's probably going to erase, but I'm going to write it down anyway. Then I'm going to do my other intersection. So click intersect, move that over here, hit intersect, 5.61. So we had 3.30 and 5.61. Now these are both equal to where those meet, so these ends will both have brackets on them. This one again went from negative infinity to 0.43. That had a bracket. This had a parenthesis because we can't be on infinity, joined with the union sign. So this section is lower, that little section there is lower. So we do the same thing we did on 1, 2, and 3, where we find our intersections, but then we look to see which section's lower or which section is higher if we're doing greater. So our answer should look something like that. Okay, number 5, we are figuring out where the cosine of x is less than 0.2x minus 1. So again, we're going to graph y equals the cosine of x. We're going to graph y equals 0.2x minus 1. We're going to figure out where it's less than. So going over to my graphing calculator, hit y equals, I'm going to clear out those ones that are in there already. And so I'm going to graph for number 5, cosine of x for my first one. So cosine the xt theta n key. My second one, I am going to do 0.2x minus 1. So 0.2 xt theta minus 1. So cosine of x, 0.2x minus 1. I'm going to hit graph. I want to find the sections where it's less than. Well, I'm less than down here between these two places. I'm less than here and all the way on. And so again, I want to find my 3 intersections and write them in interval notation. Now this time we're just less than, not less than or equal to, so we're going to use parentheses. So we'll have our first interval, our union, and then our second interval will end up going to positive infinity when I find what that intersection is. So I want to find my first 2 intersections so I can fill in my first set here. Of course, that's going to erase when I have to touch the board to find the intersections, but I'm going to go ahead and hit intersect here. And so my first intersection, 2.1719, so 2.17 is where I would start. Again, that's going to erase because I have to go to the next intersection, so get to the OK, hit intersect, find my second one, hit intersect there, 4.640, 4.64. So our first one was at 2.7 or 2.17, 2.17 to 4.64. That's going to be our first interval. And then our second one here, if I go back to intersect and find my third intersection way down here on the end, intersect 7.362. So 7.36 since it's 7.362, and that's going to go to positive infinity. So again, I'm going to have 2.16 to, or 2.17 to 4.64 union, and then 7.36 to infinity. course, when I hit this, it's going to erase the board, but I want to show you where you're at here, so I'm going to hit OK. So, this was the 2.17 to my 4.64. That was your first interval that's less than, that's lower than our line. Our second one here started at 7.36. And then this is just going to keep going and going, while that line's just going to keep going up here. So it's going to go off to infinity. And so our answer is going to look like that. 2.17 to 4.64, or 7.36 to positive infinity. Again, all parentheses because we didn't have the equal to underneath our inequality sign. And number 6 here. Number 6, this time we're doing the sine of x is greater than or equal to negative 0.3x plus 1. So, going to y equals, clearing out our graphs. First one, we want sine of x, so sine of x. The second one we said was negative 0.3x, so again use the subtraction for the negative. 0.3x plus 1, I believe it was, plus 1. And so we're going to graph those. This time we said we wanted to find where we were greater than or equal to. So greater than or equal to will be this little intersection here, and then from here this is going to keep going and that line's going to keep going down. So that's going to go off to infinity. But because it does have the equal to, we are going to include those endpoints. So our first intersection will have brackets on both ends. Our second one's going to have a bracket and then go to infinity. So infinity, of course, is going to have parentheses on it. So again, we want to find our 3 intersections. And so I'm going to hit intersect. My first intersection, if I drag that over and hit intersect, 0.843. So 0.84 would start my answer. Of course, again, I have to clear it so that I can get back to my graph. Intersect, find my second intersection, hit intersect there, 3.059, so 3.06. So we went from 0.84 to 3.06. And that was going to be this first little part up here that's above my line since I'm doing greater than or equal to. I then have to do my second section, which is going to start right here. So again, I've got to clear my board so I can find my intersection and drag that over to that third intersection, hit intersect, 5.554, so 5.55. We'll go to positive infinity. Again, this will have a bracket because we are equal to, but we can't get into infinity. And so, again, our first section that we had was 0.84 to 3.06. And then we had the union sign, 5.55 to infinity. So here we had the 0.84 to the 3.06. Here we started at 5.55, and that one just keeps going on to infinity. So if I'm looking for greater than, where is it above the line? Less than, where is below the line? If it has the equal to, we have the brackets on our intersection. If it doesn't have the equal to, we just have parentheses. All right, 7, 8, 9, we are solving trigonometric equations involving squared functions. Again, on these ones, we're not staying between 0 and 2 pi. We're doing all of the multiples. Sine, cosine, secant, and cosecant normally have a period of 2 pi and have 2 answers for each one. Tangent and cotangent normally have a period of pi because they have 2 answers, but there are multiples of 180 apart from each other, and so we can combine them into one expression. We'll get to that. You will want to have the sheet handy that we've used for a whole lot of problems. where we can look up the tangent and cotangent and all of those things. So if you don't have that paper out, make sure you get that paper out. Find it in one of your note sheets. And so if I go back here, it says 3 tangent squared of x minus 1 equals 0. We're going to solve it for the tangent. So of course, first of all, we're going to plus our 1. 3 tangent squared of x equals 1. Divide by 3. Tangent squared of x equals 1/3. Then we have to solve that for x, so we end up having to take the square root of both sides. And when we do the square root, we have to have plus or minus our answer. So the tangent of x is going to equal plus or minus. I'm going to rationalize my denominator. So I would have 3/9, so I'd end up with the square root of 3 over the square root of 9, which is 3. So I have the tangent of x equals plus or minus the square root of 3 over 3. So if I grab my paper and I look under my tangent column, I have square root of 3 over 3 being at pi over 6. And then it should be at 180 from that. So if I go down looking under tangent for another positive square root of 3 over 3, that's at 7 pi over 6. Those are 180 degrees apart from each other. One's at 30 and one's at 210. So this can be combined into one answer. Pi over 6 plus k pi, where k is an element of z. So that's going to be one of my solutions. I'm then going to connect it with the word or. Looking for the negative square root of 3 over 3. I have negative square root of 3 over 3 at 5 pi over 6. And then if I keep looking down, it is at 11 pi over 6. Again, those are 180 degrees or pi apart from each other. If I take 1/6 pi plus 1 pi, I would get 7 pi. If I take 5/6 pi plus 1 pi, I get 11 pi over 6. So again, these two can be combined into one answer. And so I'm going to have 5 pi over 6 plus k pi, with k being an element of z being one of the integers. So pi over 6 plus pi gives me 7 pi over 6, and then I go plus pi and get the next one and the next one and the next one. Same thing here. 5 pi over 6 is my first one. If I add pi to it, I get the 11 pi over 6, and then I keep going around and around and around and around my circle a whole bunch of times. So those would be my answers. Number 8, I'm going to move the board up here. So number 8, we're doing cotangent squared. Again, we want to solve it, so we're going to add our 1. 3 cotangent. Cotangent squared of x equals 1. We're going to divide by the 3. So cotangent squared of x equals 1/3. We then have to do the square root of both sides. So cotangent of x is going to equal plus or minus. Again, if I rationalize my denominator, I get the square root of 3 over 3. So this time, same kind of thing. We're just looking for the cotangent of x. So looking under my cotangent column, square root of 3 over 3 is at pi over 3. And then if I keep going down, it is also at 4 pi over 3. Again, if I took 1/3 plus 1, I get 4/3, so that can be combined. Pi over 3 plus k pi, where k is an element of z. Or, if I do my negative, looking for negative square root of 3 over 3, I'm at 2 pi over 3, and also at 5 pi over 3. Again, if you take 2 pi over 3 plus 1 pi, you end up with 5 pi over 3. And so I'm going to combine that into 2 pi over 3 plus k pi, with k being an element of z. Normally on tangent and cotangent, these two are going to be pi apart, these two are going to be 1 pi apart, and so you'll be able to combine them and only have to put in 2 answers instead of putting in 4 answers. Number 9, this time we have a cosecant. So on cosecant, like sine and cosine, I'm probably going to end up with 4 answers instead of just having 2 because I'm not going to be able to combine them together, or I might not be able to combine them together. First, we better solve this. So first of all, I'm just going to move my 2 over to the other side. So cosecant squared of x equals 2. I have to do the square root. So cosecant of x is going to equal plus or minus the square root of 2. So looking for the positive square root of 2 answer under my cosecant, I'm at pi over 4. Keep going down my list for my positive square root of 2. I'm at 3 pi over 4. If I look at my list under my cosecant for my negative square root of 2, I'm at 5 pi over 4. And if I go down my list again under my cosecant, I'm at 7 pi over 4. Now normally I would have to put all 4 of them together, but if you notice, if I take 1/4 plus 1/2, I'm going to get my 3/4 pi. So what I'm doing is I have a 45-degree angle, and then I have my 135-degree angle, and then I have my 225-degree angle, then I have my 315-degree angle. Well, if I go from 45 to 135, I'm going to add 90 degrees each time. So this would be plus 90, this would be plus 90, this will be plus 90. So I can combine all of that into one answer since each of those are 90 degrees apart. I'm going to start off with my pi over 4 plus, instead of doing k pi, which is 180 degrees, I'm going to do k pi over 2. 180 divided by 2 is 90. So I'm going to take pi over 4, I'm going to add 90 to get 3 pi over 4, I'm going to add 90 to get to 5 pi over 4, I'm going to add 90 to get to 7 pi over 4, and then I'm just going to keep going around my circle. Again, k has to be an element of z. So normally with sine, cosine, secant, and cosecant, I would have all 4 of these answers with the plus 2k pi, but since this one happened to all be 90 degrees apart, they all got combined into one big long answer. Won't happen a lot. 10, 11, 12, solving a trigonometric equation involving a squared function. These ones we're going to solve by factoring them out. Again, oops, I'm going to want to have my table so that when I'm done solving for sine, cosine, tangent, whatever it may be, I can look up my values from my table. So I want to make sure I have my table handy. Going back over here then to number 10, because my board moved. So number 10, we have 2 cosine squared of x minus 7 cosine of x plus 3. You can think of this without the word cosine in there. If I had 2x squared minus 7x plus 3 and I wanted to solve that, how would I factor it out? Well, I'm going to have my 2 sets of parentheses. For 2x squared, I'd have to have 2x times x. So I would have 2 times the cosine of x times the cosine of x. 2 cosine of x times cosine of x is 2 cosine squared of x. Since the end is positive, both signs are the same as the middle, negative and a negative, I want the factors of 3, so I add up to the 7. So I'm going to have to take my 3 times my 1. So 2 cosine of x times minus 3 would be minus 6 cosine of x, minus 1 cosine of x in the middle. Negative 6 minus 1 is negative 7, so I have it factored out. But if you're not sure, factor it without the word cosine and say, okay, x and x, a minus and a minus. Whoops, no, I'd have to have 2x and x, a minus and a minus. And then 3 and 1 would give me 6 minus 1, which is 7. And then just substitute your cosine in there. So if it helps, leave the word cosine out and factor it that way, and then stick it back in there. So I'm really going to solve 2 separate problems. Either this equals 0 or this equals 0. Just to save myself some space, I need to move my 1 over. So 2 cosine of x would equal 1. Divide by my 2, so cosine of x would equal 1/2. Here I'm just going to move my 3 over, so cosine of x equals 3. Now again, on these ones, we're not doing it between the interval. We're going to add the 2k pi on the end unless we can combine it and shorten it up. So first thing I'm going to do is look for where my cosine of x equals 1/2. Cosine equals 1/2 at pi over 3. And looking down my list, doesn't equal 1/2 again until 5 pi over 3. Looking for where the cosine of x equals 3. If I look down my list, there is not a single one where it equals 3. So I'm going to put in my two answers. I'm going to either have pi over 3. Since my period of cosine is 2 pi, I'm going to have the 2k pi with k being an element of z. Or I'm going to have my other answer, 5 pi over 3 with 2k pi and k being an element of z. So both of those will go in for your solution. If we look at number 11, I need to factor this one. Notice on this one, I can factor out the sine of x. So I'm going to put the sine of x in front. What I would have is 2 sine of x plus 1 equals 0. Again, if it helps, put it as 2x squared plus x and see how you can factor that. That's how that would factor out. So either the sine of x would equal 0, or 2 sine of x is going to equal, I'm going to move my 1 over, so it's going to be -1, which means the sine of x equals -1/2. And then I'm going to look down my chart. So the sine of x equals 0 at 0, and also at pi. Those two I'm going to be able to combine into an answer then. Sine of x equals -1/2. -1/2 would be at 7 pi over 6. And -1/2 is also at 11 pi over 6. Those ones I can't combine together. So I'm actually going to have 3 answers. This answer is going to go together. I would say 0 plus k pi, with k being an element of z. But I really don't need the 0 in front of that. So every pi, I'm going to be at 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, so forth. So I don't need the 0. I'm just going to put in k pi with k being an element of z. Or, over here to these two answers. These ones are not 180 degrees apart, and sine has a period of 2 pi. So I'm going to have 7 pi over 6 plus 2k pi, with k being an element of z. Or I'm going to have 11 pi over 6 plus my 2k pi, again with k being an element of z. So all 3 of those are going to go in for your solution. Normally I will have 4, but this one I could combine together. 0 plus k pi, which is just k pi. And then I have my 7 pi over 6 plus 2k pi, and my 11 pi over 6 plus 2k pi. And number 12, this time I'm doing secant. So, factoring that with my 2 sets of parentheses, secant squared would be secant of x times secant of x. The end is a negative, so 1 plus and 1 minus. I want a minus in the middle, so I'd have to have a -2 and a +1 to equal my 0. So either the secant of x is going to equal, that will become -1 when I move it over, or secant of x, that will be 2 when I move it over. So looking under my secant column for -1, at pi, and that's my only answer there, secant of x equals 2. At pi over 3, secant of x equals +2. At 5 pi over 3. So again, on this one, I'm going to end up having 3 answers. None of them can be combined. So I'm going to have pi plus 2k pi, with k being an element of z. Or I'm going to have pi over 3 plus my 2k pi, with k being an element of z, or I'm going to have 5 pi over 3 plus my 2k pi with k being an element of z. Normally sine, cosine, secant, and cosecant has a period of 2 pi, so that's normally how your answers will be, unless, like I said, for some reason you can combine them, and then you could. (13, 14, 15), we're solving trigonometric equations using more than one function. So we're going to substitute in and try to get them written either in terms of all the same function, or sometimes they have more than one and you end up having to factor them out. Again, you're going to want to have this table handy so that you can go ahead and look up the values once you have your equation solved. You also will need some of your identities. So you'll want to have your sheet with your Pythagorean identities, your double angle identities, all of those different identities that we used before, because we might need to substitute in by using one of our identities. So find your identities if you don't have those sheets handy. The ones with the Pythagorean is probably the most common one that you're going to use, or your double angle ones, depending on what we have here. I think most of these are just using the Pythagorean one. So for our Pythagorean identity, sine squared of x plus cosine squared of x equals 1. Therefore, sine squared of x would equal 1 minus the cosine squared of x, or cosine squared of x equals 1 minus the sine squared of x. Those are the most common ones you're going to substitute in for. You don't always substitute in, but most of the time we're going to try to do that to see if we can get it in terms of the same term. So if I have negative cosine of x minus sine squared of x minus 1, I'm going to have negative cosine of x equals minus, and in for the sine squared of x, I'm going to use 1 minus cosine squared. Then I'm going to simplify that. So negative cosine of x equals negative 1 plus the cosine squared of x minus 1. Solving that so that my cosine squared is positive means I would add my cosine of x. So 0 equals the cosine squared of x plus the cosine of x minus 2. Now I'm going to solve these like the previous ones by factoring. So I'm going to have the cosine of x, that's my cosine squared. The end is negative, so 1 plus and 1 minus. I want a positive in the middle, so I need a plus 2 and a minus 1. So either the cosine of x is going to equal a negative 2, or the cosine of x is going to equal a positive 1 when I move my numbers to the other side, since those are equal to 0. So then I'm going to look them up in my table. So looking for the negative 2. Cosine of x equals negative 2. If I look down my list, there are none for that one. Cosine of x equals 1. At 0, just at 0 and 2 pi. So in this case, I'm just going to have one answer. Again, normally I have 0 plus 2k pi, but I don't need the 0 in front. So just 2k pi with k being an element of z. So if k was 0, I'd have 0. If k is 1, I'm going to have 2 pi. If k is 2, I'm going to have 4 pi, and so forth and so on. Number 14. I have 2 sine squared of x equals 2 minus cosine of x. Again, since this has cosine, I'm going to substitute in there and say 2 times 1 minus the cosine squared of x equals 2 minus the cosine of x. So 2 minus 2 cosine squared of x equals 2 minus the cosine of x. Since I want my cosine squared to be positive, I'm going to move these two things over here. So I'm going to subtract my 2, which happens to cancel that out, and add my 2 cosine squared of x. So 0 equals 2 cosine squared of x minus the cosine of x. Factoring that, I can take out one of my cosines, which leaves me 2 cosine of x minus 1. So either the cosine of x equals 0 or 2 cosine of x equals a positive 1, cosine of x equals positive 1/2 then. So looking up in my table for the cosine equals 0, I am at pi over 2. Cosine equals 0 at 3 pi over 2. Those ones I'm going to be able to combine because they're 90 degrees apart, or not 90, 180 degrees apart. 1/2 pi over 3. Cosine of x equals 1/2 at 5 pi over 3. Those ones I'm not going to be able to combine. They're more than pi apart. And so, putting this into one answer, since I can add pi to get to 3 pi over 2, I'm going to have pi over 2 plus just a k pi, with k being an element of z, or can't combine those ones, and those periods are 2 pi, so pi over 3 plus 2k pi, with k being an element of z, or 5 pi over 3 plus 2k pi, with k being an element of z. And so in this one, whoop, my box didn't draw. Those three things would go in for my answer. All right, number 15. Now you notice we have a different one. We have cotangent squared. Our cotangent squared of x is equal to the cosecant squared of x minus 1. Again, that's one of your Pythagorean identities. So you can look up your Pythagorean identity. Cotangent squared of x equals the cosecant squared of x minus 1. So, substituting in for my cotangent squared, I would have the cosecant squared of x minus 1 minus the cosecant of x equals 1. So, cosecant squared of x minus 1 minus the cosecant of x, that would be minus 1 when I move that over. So cosecant squared of x minus cosecant of x minus 2 equals 0. Factoring, cosecant of x, cosecant of x, and cosecant of x is cosecant squared. I've got a plus and a minus. Since I have a minus on the end, I want a minus in the middle, so minus 2 and plus 1 equals 0. So cosecant of x would equal negative 1, or cosecant of x would equal positive 2. So looking those up, cosecant of x equaling negative 1. Only one I find is 3 pi over 2. Cosecant of x equaling a positive 2 pi over 3. Cosecant of x equals positive 2. Oops. That was under secant. Let's try that again. Cosecant. Under cosecant of x equals positive 2, I'm at pi over 6 or 5 pi over 6. And again, those aren't 180 degrees apart. So I'm going to have 3 pi over 2 plus 2k pi, with k being an element of z, Or I'm going to have pi over 6 plus 2k pi, with k being an element of z. Or I'm going to have 5 pi over 6 plus 2k pi, with k being an element of z. And those would go in for my answer.